In this practical, we're going to construct a De Bruijn graph from a string. So I'm going to create a function here, De Bruijnize, which will take a string for which we want to construct a graph and a k-mer k that we want to use. And so if you recall from lecture, what we want to do is look at each k-mer in this string, take the two k-1 mers in that k-mer, and create an edge between those two k-1 mers, and create nodes for them if they don't exist. So I'm going to create my list of edges and a set of nodes that will represent this graph. And now I'm going to loop through every k-mer in the string. So I is going to range from 0 up to the last position where a k-mer could start. And so for this k-mer now, I want to add to edges. I'm going to represent this edge as a tuple. So it will be the k-1 mer starting at I and going up to I plus k-1. And then the other k-mer will be starting at I plus 1 and going up to I plus k.
Yeah. So that's the left and the right k-1 mers.
Mm-hmm. And now we just have to add both of these to our set of nodes. So I'll add the first k-1 mer. And the second k-1 mer.
And because you're using a Python set, if you call add more than one time with the same string, it'll only add it once.
Right. And then we can just return our set of nodes and edges. So this is our De Bruijnize function. So let's run this on a simple DNA sequence. I'll use a k-mer length of 3. Oh. There we go. Now let's print out our set of nodes.
Okay. We've got AC, we've got CG, we've got GC, we've got GT. Looks like we got all of them.
Yeah, and so since our k-mer length is 3, every k-1 mer in this string should appear in our set of nodes.
Yeah.
And it looks like they're all there. And now we can print out our set of edges. And so we have an edge from AC to CG, that's from the first k-mer. CG to GC is the second k-mer, and so on for each k-mer in that.
Yeah, in fact, those edges in that order are the Eulerian walk for this De Bruijn graph.
Right. So I'm going to paste in here a function that we'll use to visualize this graph. All this function does is, you can see the first line, it calls our function De Bruijnize, and then it prints out the nodes and edges in a special string that we can pass to dot, so that we can visualize this with dot. So now I'm going to load a GVMagick.
So this is a special IPython plugin that lets us draw graphs, basically.
Yep, and then I'll call dot visualize with our function visualize De Bruijn, and I'll just paste in the string and k-mer from above, and here's our graph. So you can see we start with AC, and this goes to CG for the first k-mer. Second k-mer, we start with CG and then go to GC, and back to CG, and then to GT, and then TC, and then CG, and then we're done.
Yep. So you can easily see the Eulerian walk when you print out this nice small graph.
Yep.